Okay, good morning. Good morning, everybody. It's good to see that some people at least are in the room. As you know, it's first session of today. It's the last day of the conference, and there is a national strike just outside. So I guess this is the reason why there are not so many people in the room yet. So, okay, people are still coming in, so please have a seat. In the meantime, I will briefly introduce the session before giving the floor to our guest speakers. So my name is Cerneaz. I work for CINEA, which is the executive agency of the European Commission dealing with climate, infrastructure, and environment. And we are all here for this session, session 15, on zero-emission heavy-duty vehicles. So if you have, now a couple of words about the context. So if you were already here for the previous session that were presented as part of the conference, I would say you know the context. So it's no secret that the goal, the ambition of the European Commission is to achieve climate neutrality by 2050. There is an overarching strategy to achieve this goal. Is the well-known Green Deal. DG RTD, in the opening speech with Rosalinde van der Vlies, came back on this, so she recalled that this ambition is still there. And of course, transport is part of this picture. And the Commission has put in place a series of initiatives to reduce our reliance on fossil fuels, to reduce greenhouse gas emission, to improve air quality across the continent, as well to foster innovation, to foster technological advancement. So we are going to hear about that in this session, and the focus, as I said, is going to be on heavy-duty vehicles. So you have probably noticed that this is the only session focusing entirely on this category of vehicles. So it's a special session, so you made the right choice to be here today with us. It's a special category of vehicles because it's very difficult to achieve zero emissions for different reasons. So the challenges are many, but just to name some of them. So first of all, I would say is energy density, is also related to range. So at the moment, the technology, especially for the batteries, which is available, doesn't allow to achieve the range which is expected by this category of vehicles, especially, as I said, for long haul, without increasingly massively the weight. So that is an issue. Another issue is space and payload, because both batteries and the tanks which are used for the hydrogen take space, and this space is meant to be used for the transportation of goods and passengers. Infrastructure is another issue. We know that the situation is far from being ideal for passenger cars, where, well, for heavy-duty vehicles, long haul, the situation is even worse. We will hear about that in the presentations. Cost is certainly another issue, because it's true that many studies are showing that operational costs, so fuel, maintenance, might be lower compared to conventional vehicles, but that is certainly not the case for the acquisition cost, and that is a barrier. And then I would say another challenge is regulation, especially when we consider long haul and international operations. So this is just to depict a brief picture of where we sit with this session. So here you have on the screen, you have an overview of the 4 projects that will be presented today. So we have ZEFES, Empower, and Escalate. These are 3 projects focused on the trucks, heavy trucks, for long-haul applications. Technologies which are investigated are both battery and fuel cells. And then the fourth project that will be presented is EBRT 2030. And in this case, the vehicle which is considered, so the category of vehicle is buses. And the aim of the project is really to improve public transportation via electrification. So before I pass the floor to our guest speakers, maybe just a reminder of the rules. I guess you have been here for the past 2 days, so you know what the rules are, but just quick reminder. First of all, to the speakers, so you have 15 minutes. So when you will come close to the 15 minutes, we will make sure that you get the message that you're getting close. I think Ian from Bosch, so my co-moderator for today, he has cards, yellow cards, red cards, so this is, the message will be there. And to the audience, as you know, we have, so we are starting with the presentations. There is possibility to ask quick questions about specific aspects that were presented. So this we can do in between of the presentation if we have time. Otherwise, there is a discussion time which is already foreseen at the end, and you will have the time, the possibility to ask your questions there. And that part of the session will be moderated by Mr. Faye, so Ian. So you will be opening and moderating the question coming from the audience. Okay, so if there are no questions, I propose that we start with the presentation. We are here for that. Okay, so the first presentation for today is from Project ZEFES. We have two speakers. So we have Mr. Krijgenhagen and Professor Hegazi, both from VUB University here in Brussels. So Mr. Krijgenhagen is an expert in the domain, and in particular when it comes to transport of freight. He worked for many years for European truck OEMs, and he's now part of VUB and part of the coordination team of Project ZEFES. Professor Hegazi works for VUB, and so he's professor there, and he's also founder and leader of the research group ePowers. So if you're ready, the floor is yours.
Thank you. Thanks a lot, Eric, for a very nice introduction. I'm happy that I see you here, even with a strike. I have bad experience today morning. I have 2 hours to reach here. Congratulations to come here to support also this logistic and also heavy-duty session electrification. So, as already highlighted by Eric, I and Ben today will dive in the ZEFES project to present you what we have achieved already in the projects, and see also the synergy with other projects in heavy duty. So you can imagine that we start this project in 2023, and it's very challenging project because we are also coming from not importance project, but also is needed. So I like the word is needed for electrification, but here you can see the project is, you can see the title also is tackling the zero emission flexible vehicle platform with modular powertrain. I would like also to highlight what does mean modular, what the key item behind that later. Zero emission, of course, we are targeting to make fully electrification for this heavy duty. Of course, that we consider also the long haul emission profile and also the whole ecosystem. You can see it's very large projects. We are 40 partners. As you can see here, I couldn't read from the screen, but okay. 6 OEMs, and we have 14 suppliers. We have 11 shippers and also 9 research institutes. We had also asked for a funding of 39 million, and we had funded 23. Of course, we have also associated partner what I call from Switzerland is Hitachi also there to support also in the project. As you can see here, we start in January 23, and also we have already 42 months, but of course, due to the fact that challenges in the projects, we have also asked for extension for 6 months, it will be 40. As you can see here, that we have covered all the value chain, and also we consider a very strong stakeholder group. That last October we had very nice, successful symposium for ZEFES that we aggregate or collect a lot of information about logistic needs and also requirements for infrastructure and policies. As you can see also from this vision that we can create impact, this is why we also come to the idea that we create a very nice virtual cluster for heavy-duty vehicles that also ask or invited also some other projects that really in the field of electrification of heavy duty. You can see also here we have Empower, Escalate, also that we present later, and we have More Life. More Life is more for degradation test and durability test for fuel cell, because it's very important component today for heavy duty trucks that will be also tackled in ZEFES later. And also other project, we have also Rail Hi-Fi, also fuel cell, also hydrogen. So we aggregate also most of the heavy duty activities in different areas. And of course, our aim is to create impact in several areas. The first one is to see the energy infrastructure, how we can tackle this challenge. Of course, there's also a lot of infrastructure projects. The CIF also, we have also collaboration, also discussion with infrastructure projects that are coming from CIF projects, and also German also activity there in like HOLA project for mega charger, but also not only that, but also we cover life cycle assessment and TCO. And of course, digitalization. I heard yesterday there is a lot of activity in logistic for tools and so on. But today also we have a very nice outcome from the project for digitalization tools and so on. I will dive again for our ambition at the beginning of the project. You can see we are targeting to demonstrate long-haul trucks, fuel cell and battery electric vehicles, mega charger, and also refuel stations. So the idea is to optimize also the location for this mega charger. Second one is to create a pathway for affordable heavy-duty vehicles to fit the need or to comply with the need of logistic companies. And then we can make mapping of mega charger and refuel station. That is really important for all the project heavy duty, because that is really the need of today, and we need to push forward to get more in line to accelerate the electrification. And then you can see also, I highlight also in the title of the project, there is a modularity. Modularity for powertrain is very important because we are tackling two systems, different requirements and specification, fuel cell and battery. Every also system has its own needs, and we need to cover this one, offering a very nice modular approach to the end user, and in this case, the logistic companies. And then we have also digitalization and also digital twins that we are going to present later, the way of getting a very nice kit tool, what we call multiple tools that will be used for assessing and also boosting the electrification, reducing the time of development of the car, also reducing the time of managing the fleet as well. And then we can see also what that means for the energy efficiency and also reliability of the system and robustness, and also the society business model and so on. And today also I would like to highlight that today we have later what we call a workshop as coming from a veto cluster on LCA and TCO, where we need to have a common definition of LCA for heavy duty and also TCO definition as well, and what should be considered, what shouldn't be considered. Of course, at the beginning of the project, we have a lot of assumption that we consider by default will be there. But during the execution of the project, we discover a lot of challenge. And today also, my colleague Ben will highlight also this challenge that we face during the ZEFES project and how we are going to tackle them. Yeah.
Thank you, Omar, for the short introduction. Yes, talking about assumptions, I think today we should talk about what are the lessons learned so far and what can we do about it, and how should we act beyond the project and even during the course of the project. We had made some assumptions. It was about the infrastructure, that we assume at certain places we would have charging points and HRS points. we also had the assumption that the directive on weight and dimension would be adopted by many European countries where we are crossing. In fact, this is all not reality, and we had to decide that we organize 4 working groups in our project with stakeholders. And that is the lessons learned, number 1, in this project, that we have to collaborate with stakeholders on national level, on regional level, but also with associations who are representing motorways, who are representing parking places, the DSOs, the CPOs, and the executive bodies, because a type approval of a vehicle doesn't mean I can run on a certain road with a vehicle. So we found out very quickly that out of Work Package 1, we need to have a first working group which is talk to stakeholders from each relevant area the project is confronted with. Secondly, we were able to develop our platform to design optimized powertrains, and we are ready with our digital twin, which I will explain a little bit in the next chart. Lesson number 2 out of this project is the infrastructure. We need the support from DSOs, we need the support from CPOs to really make it possible that you can do long-haul freight transport across Europe. And this picture shows the complexity of our project because we have 15 demonstrations across Europe. The card of Europe shows that we have 2 corridors, the one from Sweden down to the south of Spain, and one from the west of Benelux down to deep in Austria, deep in Italy. And managing these challenges, talking to national governments, DSOs, CPOs, to find the right charging points at the right location in line with the legislation of drive and rest times, that's a real challenge, I can assure you. On the other hand, we have designed our portfolio of demonstrations in line with previous projects, Transformers and Aeroflex, where we made in-depth analysis about what are the main corridors, what are the main missions, and we really covered, in my view, most of the missions which are really relevant for European freight transport when it's about cross-border. And 2 demonstrations are pipelines. And it is not so much the case about, oh, it is so long. No, it's a pipeline. And a pipeline means I'm transporting fresh fruits to somewhere in Europe along this pipeline. So it means the truck doesn't necessarily end in Halmstad, Sweden. It can end in Düsseldorf because I have 5 days to bring the fresh fruit into the supermarket. When something is not happening as I want, I have to decide somewhere along this pipeline, I'm not traveling to Halmstad, no, I go to Aachen or Düsseldorf. So, and that is an additional complexity in freight transport across Europe. And for that, we are happy with this variety on demonstrations, because then you can really see per category of freight, you can make a set of KPIs, and you see what are the challenges and the barriers. Coming to the digital twin, and you see also a small video, we have added a very important issue in the digital twin, and that means the right truck at the right time, at the right part of the infrastructure. Because we found out the trucks which are electrified will become 900 millimeter longer. In first instance, you will say, well, that's not important. But suddenly, we have discovered that at national and regional government level, it is immensely important. And we have a huge discussion with ProRail in the Netherlands, who are really blocking the 900 millimeter. Because a railway crossing, behind that, it can be a traffic light, and there you go, the truck is too long. So we really have to be careful. How are we implementing such new regulation to make sure that vehicles can run? We also are now in a test phase of our digital twin, and our digital twin is ready for the next project beyond ZEFES. This is the strategy tools and concepts for heavy-duty vehicles which are electrified. And this digital twin, I think we can be very proud of it, because it's not only a buying tool, it is this right vehicle at the right place for the right duty. And it is a digital twin which is a complete one, which really can monitor the mission the truck driver or the LSP needs to do. And that brings me to the long-term perspective out of this project. We know that by 2028, 2040, we have a certain high number of e-trucks on European roads, because these are figures coming from the OEMs, because they are going to sell these trucks, whether people like it or not, because this is the only way to come to a zero-emission freight transport in Europe. And that makes it so important that we really talk to stakeholders to take the people with us on our train to a zero-emission situation. And one important issue in this is that freight transport is very complex. It starts somewhere in a factory where products are created. They are distributed through the whole of Europe, even through the whole of the world. And in between, you have this intermodality, which is also built in our project. That means part of our demonstrators are moved by train. And during the movement on the train, they will be charged. The batteries will be charged to allow that when the vehicle arrives at the destination, the vehicle can start running. So all these complexities is also asking from all these people, which are from the other stakeholders, create another way of logistics in the freight transport. Look at couple points where you have intermodality. Look at how can I use 24 hours my infrastructure, and start to talk about intelligent access to infrastructure, including the use of EMS vehicles, because that can save costs in implementing e-trucks, which are today unfortunately too expensive because of the not yet high volumes we have available for these vehicles. And that brings me already to the end of the presentation. I thought, as we talk today about challenges, barriers, and what do we need to do, we have some takeaways. And one important, yeah, I'm nearly finished, so be quiet. So we see constantly with each demonstration the new challenges and barriers are raising. The digital twin we need to develop further in collaboration with all these stakeholders. The DSOs, we need them, because without DSOs we will not be able to have the charging points. The EU member states need to approve the revised weight and dimension directive, otherwise we cannot do cross-border in some countries. Last but not least, the vehicles and the charging technologies are there. I'm not worried, because we will build these vehicles, we will build these MCS chargers, but the stakeholders have to collaborate with us to make it work. And I think this should be the discussion of today. Thank you very much.
Okay. Thank you. Thank you very much for both speakers. I think, you know, it's very good. When I think about this conference, I think it's good that, of course, is a very nice opportunity for all of us to network with other companies, with other stakeholders. It's good to hear from projects about their successes, but it's also very good to hear, as you did in your presentation, to hear about the challenges, to hear about the roadblocks, because this is a lessons learned, something that we can build on in future projects. So thank you again for your nice presentation. So I'm going to introduce now the next speaker. Okay, so the next project to be presented is Project Empower. The speaker is Mr. De Gennaro. He's head of the competence unit Electric Vehicle Technologies at AIT, so the Austrian Institute of Technology. And Mr. De Gennaro is also president of EARPA, which is the European Association of Automotive R&D Organizations. So if you're ready, Mr. De Gennaro, you can come here, and the floor is yours.
Thanks, Eric, for this kind introduction, and thanks to you all for being here despite the challenging condition of this morning. So I nearly missed it, so that was a near miss also for me. I'm glad today to present the Project Empower. The Project Empower is the largest European projects by funding that it's coordinated by my unit at AT, and it's definitely an element that is a matter of pride for us to be involved in such an activity. So Empower stands for eco-operated, modular, highly efficient, and flexible multi-POWERtrain for long-haul heavy-duty vehicles. And the topic of the project is the same of our sister project, ZEFES, that you have just seen, and Escalate. The consortium, though, is quite different. So compared to our sister project, is a much smaller consortium. We are only 14 partners from 4 European member states plus Switzerland, and for a total funding of slightly above 18 million. The project has been funded by the Class of 5, Destination 5, 01, 08 identifier topic of the year 2022, and it's now more or less at its midterm. So we are 24 months out of 48 into the project. It's an innovation action, as our sister project. And the main element that differentiates us is that we have a single OEM into the consortium. So we have a mono OEM consortium, and this is done on purpose to concentrate activities as much as possible in technical development and ensure modularity and transferability between components. So the projects aim at developing and demonstrating on European roads 2 heavy-duty 40-ton vehicles, both belonging to our, both branded by our reference OEM Iveco. The first is a fuel cell electric vehicle for long-haul operation with a maximum unfueled driving range of 750 kilometers. So this is driven by a fuel cell system. And helped by a battery for power overboost. And the second demonstrator is a battery electric heavy-duty vehicle for regionally delivery mission profile with a maximum unrecharged driving range of 400 kilometers. Both vehicles are based on the same chassis. Both vehicles share plenty of components. This is for us important, and this is also linked into the strategy of the project itself, sharing components and ensure as much as modularity as possible between these 2 platforms is for us, of course, a driver for innovation, but also a driver for maturing this technology and bringing them on the European roads at the lowest possible cost. Cost reduction, as Eric said at the beginning, is critical to ensure the deployability of such a technology. Both vehicles have the same gross weight, vehicle weight of 40 tons, and they are expected to be demonstrated on European roads at TRL 8 by the end of the project. So let me deep dive into the results of the project. We have most of our activities which are focusing on technology development and components development, components implementation on a chassis, and vehicle demonstration at the end. So we are midterm into the project, so the results that I'm going to present can be seen as interim results, but also quite explicative of what we can expect in the second half of the project. The first result that I would like to focus on is the development of the battery pack. We start from a reference battery pack provided us by Iveco, which is called the EB S69. It's a pack that was previously developed for an Iveco bus. In its reference form, it adopts an MC532 pouch cell, so it's a Gen 2B pouch cell. It has a nominal energy of slightly below 70 kilowatt-hour at an energy density of 178 watt-hour per kilogram. This is a standard automotive product. We are working in improving this pack without changing the pack design and the pack BMS and voltage level, but by refurbishing and redesigning the pack with better and newer cell to improve the energy density. I'm not allowed to disclose all the details at the moment. So together with the development of this improved second generation pack for being equipped on our demonstrator, we are also developing, as you can see on the picture, the positioning of the battery pack on the different type of positioning on the chassis platform. We have an optimistic high development pack where we can use 5 of these battery pack in a modular way on the chassis, and then we have 2 solutions for 7 battery pack if we go back of 1 generation of cells that you can see can be displaced as a 3-1-3 or 3-2-1-2-1-1. So we are also investigating the inference on the dynamics of the vehicle by the different positioning, and we have selected the pre-final battery configuration which adopts 7 of these improved pack in the ghost picture in the way that you see on the ghost picture of the truck on the screen. The second development that and results that I would like to present is the arrangement and architecture of the hydrogen tank. So one of the 2 demonstrators is a fuel cell driven heavy-duty truck. So we have 5 tanks. Each tank is more or less 10 kilograms of gaseous hydrogen at 700 bars. And we plan to equip the vehicle demonstrator in the way that you see. So in this picture, you can see the vehicle demonstrator seen from 45 degrees on the back. So we have 3 tanks located on a supporting structure on the back of the sleeper cabin, plus 2 tanks on the 2 sides. And in between the 2 tanks, we have 1 or 2 battery pack optional, since we plan to use the battery pack as a booster for the hydrogen-driven vehicle. So de facto, this fuel cell heavy-duty vehicle is an hybrid. Hybrid in the sense between hybrid, hydrogen, and battery. We have 70 kilograms of hydrogen that can be stored into these 5 tanks, and the operational pressure is 700, according to the 700 bar standard, of course. The third result that I want to present is the state of development of the fuel cell pack. The fuel cell pack is entirely developed by FPT, so it's an Iveco product. As a power of 200 kilowatt continuous, so the fuel cell is sized to serve the chassis, the vehicle only for cruising. So again, when we need more than 200 kilowatt, we're going to using power from the battery. So this also allowed a little bit of right sizing. I don't want to speak about downsizing, but right sizing of the fuel cell system. It has an efficiency of 55%, which is pretty much high for an automotive product, and a demonstrated durability on the bench of around 20,000 hours of operation. The system is undergoing testing and will be located on the demonstrator, basically in place of the thermal engine if we want to do the comparison with conventional fuel heavy-duty vehicles, so below the cabin. The fourth result that I want to present is the state of development of the e-axle. The axle is a common element between the 2 vehicle demonstrators. So we have the same e-axle on both demonstrator. And here you can see how all the project is designed to exploit these synergies between these 2 demonstrators. It's a double motor inverter, double inverter, electric motor. The 2 motors are coupled with a differential and are powering the second axle of the vehicle. So the second axle is the only driving axle, while the other 2 are driven axles. And it's placed basically in the same position in both demonstrators. So you can see on the top the fuel cell electric vehicle, and on the bottom the battery electric vehicle. You can recognize them also because the fuel cell has the sleeper cabin and the battery has no sleeper cabin. The maximum continuous power of this double motor axle is 480 kilowatt, so at 650 volt. So we are aligning towards 600 to 800 volt electric architecture for the two vehicle demonstrator, as a max wheel torque of 36 kilonewton, and ensures a continuous speed of the vehicle of 95 kph, which is basically the requirements that we get from the OEM. It is able to start the fully loaded 40-ton vehicle on a uphill up to 18%. This was also part of the requirements identified by the end user, and there's a mileage, a durability of 1 million kilometers over 7 years, which we consider to be the usable lifetime of the vehicle itself. Together with the axle, we are also developing a new braking system. This is a Brembo product. Brembo is partner of the project. And this braking system relies on electromechanical braking pack actuator. So we are basically planning to get rid of all hydraulic and pneumatic system. This, of course, makes sense on an electrified vehicle because you remove a subsystem which can create some reliability issues. The electro-actuated mechanical braking pad system, of course, are integrating all the safety system, braking, ABS, and so on and so forth. But it also allows for a much better controllability of the braking and a much better controllability of the regenerative braking recharging system. So this is also part of our development, and we expect to equip with this system both vehicle demonstrator. And the last but not the least among the results and the area that we are developing on these vehicles is the heating, ventilation, and air conditioning system for the two cabins. So the two cabins are different because the fuel cell electric vehicle is intended to be a long-haul product. So we have equipped it with a sleeper cabin. So the driver has the possibility to sleep in the cabin. So it has a larger volume and different heating and ventilation and air conditioning requirements, while the regional demonstrator is a regional delivery truck, so it's not expected to have a sleeper cabin as a smaller cabin. So for both of them, we are redesigning and re-engineering the HVAC system based on CO2 pump and compressor, and we are performing a series of comfort measurements to understand how to best tailor this system, which is common between the two cabins, to the needs of a long-haul truck or to the needs of a regional truck. Also here, between the two demonstrators, we try to exploit as much as we can the synergies and the commonalities between the two vehicles. So as you see, we are doing innovation in different areas, so from energy storage, energy conversion, electric motor, e-axle, braking, and auxiliary system. So we are overhauling, designing, and engineering two state-of-the-art tracks. Concerning the impact that we expect, of course, we expect and we are thrilling to see this demonstrator to drive on European roads as soon as possible by the end of the project. The demonstration is expected to have two driving paths for the regional and two driving paths which are cross-border for the long-haul truck. We expect to deliver state-of-the-art and high-efficient fuel cell heavy-duty and battery electric vehicles to achieve an efficiency for the fuel cell which is above 50% tank to wheel, so that's quite something. We also are expecting to implement silicon carbide solution into the inverter of the e-axle and to reduce by 40 and 30% the requirements for auxiliary system, heating, ventilation, conditioning system in the cabin by applying this technology based on CO2 compressor. Of course, we meet the target of the project to have a payload which is 90% of the reference conventional fueled vehicles. This was a requirement of the call, and according to our estimation, we are on target to achieve that, as well as to have durability of the system, as I said before, 1 million kilometers or 7 years or 30,000 hours of operation. All the efforts that we do in Empower are, of course, targeted to put these, to demonstrate these two vehicles by 2026, 2027, so end of the project on the European roads at year 8, and possibly bring this vehicle to the market before the end of this decade in support to the objective of climate neutrality of road transport. And that's all from my side. So if you are interested in knowing more about Empower, of course you can contact me or you can contact my colleague Dragan. Many of you, I think, know him. That is the coordinator of this project. Thank you for your attention.
Okay. Thank you very much. Perfectly on time. Okay, I propose that we already move to the next speaker. So the next presentation is concern project Escalate. So the speakers are Mr. Wenu. He is project coordinator at FEV France, and the presentation will also be delivered by Professor Hartavi. She's head of the Center for Automotive Engineering at the University of Surrey in the UK. So if you want to join me here, the floor is yours, and you can start. Thank you.
Thanks, Eric, for this nice. Thanks, Eric, for this nice presentation. Yeah, Escalate deals with power Europe Union net zero by escalating zero emission for heavy duty. Our vision on this project. Sorry. Our vision in Escalate is to have this project as a pioneer for carbon neutral on the freight transport, how by developing very high efficiency, low cost, and zero emission heavy duty. Coming to the consortium, we have 37 partners and 13 countries. We have 5 manufacturers, 3 infrastructures suppliers, 4 fleet operators, 4 tier suppliers, and many RTOs. Our budget is 22 million. And coming for our objective, we have 6 main objectives as the one listed by on ZEFES. First and very challenging is to develop and demonstrate this battery, fuel cell, and range extended in a minimum of 40 tons for 750 on charge and fuel range under real-world operation conditions. The second is to have something costly, cost-effective electric multi-energy powertrain for minimum of 500 kilometers daily operation. And to develop something also that will be grid-friendly, multi-energy for fast charging solution. And we propose and have also zero heavy-duty fleet tools to be integrated in fleet operation. And to have this, we have developing, and we propose here 5 modular digital twins, and at the end, be a leader on Europe concerning logistic infrastructure. Escalate roadmap. We start with list of requirements, the pilot requirements. I have to define here the KPI list to achieve the 6 objectives we listed before. And after this, we have to define the standardized modular scalable powertrain component, as already defined here, e-motor, e-axle topology, eddy current brakes, battery, and also fuel cell modules, and in fact also onboard energy management. In the infrastructure side, we have to decide refueling, grid-friendly charging solution that will be developed and assessed through standards and protocol, with also here involving megawatt charging and also hydrogen high-speed flow. That will include also here cybersecurity. And based on the pilots and also defined component we had from the milestone 3, we will have this data we will use to define and create these 5 digital twins that will be performed and associated to tools, managerial tools as predictive maintenance and either AI tool for fleet management and also route optimization. Now after this, we have to do real-world demonstration with the physics trucks. And we've used these 3 technologies that I said, battery, fuel cell, and also range extended. We have to do it cross-border on different TNT European routes. And after this, we have to do the LCA based on AI tools and social LCA, and we have to propose to you here a kind of dynamic LCA that will be evaluated. In parallel, we've proposed to you also here, we have some demonstration you will be shown later on. We propose to you a web-based TCO tools to evaluate these 3 energy powertrain technologies based on zero-emission heavy duties. And my colleague, she will follow up and present you results we achieved so far. Thanks.
Thank you very much, Faye. And thanks for hosting us. I'm delighted to be here. And also, I would like to thank especially to Ben to get the red flag before I get it right. So thank you. He kept his promise, I should say. OK, fine. Anyhow, so sorry, I just need to hope that I can control. No, maybe. Yeah, OK, fine. So we are just started the second sprint of the project, as you may guess, and I think the challenges are already summarized very well. How we try to come over this challenge in Escalate is actually we have 3 enablers to overcome this challenge. The first one, as you can see, the modularity and then standardization of the components. Another one is the AI technologies, and I think I can easily say that we are very data-driven. And also the third one is also the digital twin technologies. So you can see some of the outputs at the end of the first sprint, which is the standardized, modular, scalable, and multi-POWERtrain solutions, which we developed in the scope of Escalate. I'm pleased to say that the first battery packs are nearly ready to be able to integrate it into our vehicles. And then we also use the AI techniques to be able to develop the highly efficient modular electrical machines and the e-axle design solutions, thanks to our colleagues. And you can see the piloting activities, which is established throughout Europe and the relevant associated countries, including UK and Turkey. The first one is the CISU pilot, which starts from Helsinki, for sure not end up in Sofia. It's impossible, I should say. It's just a small mistake which is on the slide, so I apologize for that. So it's in Finland. We have 3 different demonstration activities. We will start with 3 different modes of operation. First one will be the fully battery one, and then the second one will be the fuel cell, and the third one will be the range extended mode. So you can see the innovations here. We try to demonstrate the scalability and the transferability of our solutions. So the innovations are more or less the same. We try to implement predictive thermal management strategies, different operating modes of operation, including the eco-driving solutions and the hybrid predictive maintenance solutions. So when we are designing the solutions to overcome these challenges, we don't just concentrate on how to develop these technologies from the vehicle manufacturer perspective. We also consider the fleet operators, because they will be the main end users. And thanks to our 4 fleet operators, which is involved in the Escalate very actively. The second pilot is related to the BMC truck, which wants a fully fuel cell truck. And again, we try to demonstrate the advanced high-speed hydrogen refueling option in the innovation in this piloting activity. We are targeting 170 grams per second, refueling speed, which will be the first one in the world. I'm very pleased to say that. And we are also in preparation of the protocols regarding this, and the AI-based adaptive energy management algorithm strategies and the explainable AI solutions for the predictive maintenance will be the third innovation. And the third one is the Mercedes-Benz Pilot, which is a battery heavy-duty vehicle. The target is, again, to demonstrate these innovations, the predictive capabilities, the AI-based energy management strategies, and again, the predictive maintenance solutions, including the AI-based range estimation algorithms. And the fourth one is the electro-pilot. It will be a battery heavy-duty vehicle. We try to challenge ourselves further, and it's a refrigerator truck, right? We try to reach these ranges, including the refrigerator, because as you already know that there will be an additional energy consumption because of the refrigerator unit, and we have also some solar panels to be able to, overcome this challenge even further. And you can see the 5 innovations which we are going to implement. Again, there will be some regional tests and then real-world tests, and there will be some cross-border activities. The last one is the fourth one, which will be a fuel cell heavy-duty truck, right? Again, we are going to demonstrate the 5 innovations here, starting from the thermal management, predictive thermal management strategies, ending up with the advanced modular fuel cell solutions. And apart from that, I think one of the uniqueness of the Escalate project is we are also considering the infrastructures deeply in the scope of Escalate project. We will have 3 infrastructures. One of them will be the one which will be developed by, ENGIE, right, where we are going to demonstrate the high-speed hydrogen refueling, and the other one is developed by the ChemPower, which will be a megawatt charging solution, where we also virtually analyze the waste heat recovery system to further increase the energy efficiencies. And the last one is the modular, fuel cell station, which will be developed by Çalık. And you can see the data space which we are generating. As I said earlier on, we are very data-driven project, right? We understand the value behind this, right? And then you can see the different source of data which is coming from here, including our digital twin solutions. And again, you can see some of the techniques, methods that we are trying to implement. We all know that the importance of data, but we also know that sometimes there's a lack of data, right? And also the confidentiality of the data, where we try to eliminate this challenge by using physics-based model combined with the AI-based techniques, which gives us the solution of the hybrid techniques, right? So here you can see, and you can closely monitor. It's a bit small, but I don't know if it is visible enough for you, that we can predict the remaining useful lifetime of a battery pack, just as you can see from here, with a very, more than 90% of accuracy. So we have different KPIs to be able to evaluate this, and then until so far we developed more than 4 AI-based techniques. We make some comparative analysis, and we are combining with the hybrid technologies. So and also, when we are developing these technologies, we didn't underestimate the computational, burden that they bring, and also we didn't eliminate the energy consumption which is used by these techniques, right? We also consider this, so we come up with the sustainable AI techniques, plus, as we discussed yesterday, the explainability of these solutions to be able to go to the certification process smoothly. We also consider the explainability of these algorithms, as you can see here. And as I said, another enabler which we used to improve or to overcome this challenge was the digital twins. We come up with the 4 digital twins. Actually, right now, they are digital models, I should say, because we are in the process of building these trucks, but we are considering the bidirectional communication, of course, under the conditions that there won't be any safety critical issues. So we are in the phase of building up these digital twins. Also, we know the importance of the security, so thanks to our partners who also consider the security aspect. And you can see the dynamic LCA approach, which we are trying to implement, thanks to our partners, again, who are expert on these. So we didn't come up with a static LCA approach. We considered the dynamic LCA approach, which enables us further evaluate the performance, the sustainability aspect of these trucks in a precise manner. And you can see the KPIs which we developed and the environmental impact. And then we also developed some tools for the fleet operators. And as you can see, the tool which we developed until so far enable us to, to make some comparative analysis between the 4 different, technologies. Of course, you would like to compare as a fleet operator with respect to the internal combustion engine and plus the other techniques. So anyhow, the basic version will be available online, so you can play with this. Just then I can skip. And you can see the rope optimization techniques, which we also use. We develop using ML, machine learning. And here is the fluid HMI. Again, we try to overcome the range anxiety through the fluid interfaces, which we developed within the scope of the Escalate. We always consider the end users, not just the fleet operators, also the drivers, right, to make to increase the adoption potential of these techniques. Again, I already see the yellow card, so I will skip this. You can see the key expected outcomes of our project, right? So very briefly here, which is combined our digital twins, our AI-based techniques, and the modularities, and the wider impact. I promise you I will get this. Yeah, okay, fine. So, okay, and you can see the impact which we are targeting from 5 different perspectives, starting from the scientific innovation and ending up with the policy recommendations, where we are going to summarize this in the white papers, hopefully. So, and here are the takeaways for our key stakeholders, which we classify in 4 groups, starting from the technology providers up to the, at the policy level. And also we value the knowledge exchange. You can see the projects which we are in communication with. I'm pretty sure this will increase in the near future. And I would like to thank everyone for this kind invitation once again. Thank you.
Okay, thank you. Thank you, both of you. It's not always very easy to stick to the 15 minutes, but in the end, you speed up and you manage. Okay, so good. So this was the last presentation regarding trucks. So now we move to the next presentation, and it's also a new topic. So we are not talking about trucks anymore. We are going to talk about buses for urban and peri-urban use cases. And the project, so EBRT 2030, is also about the concept of BRT, so Bus Rapid Transfer. And the speaker is Mr. Grazian. So Mr. Grazian is going to talk about this project. Mr. Grazian is project manager at UITP, which is the International Association of Public Transport. So if you're ready, you please come here, and the floor is yours. Thank you, Mr. Grazian.
Works. Yeah. Thanks a lot for the introduction, and thanks a lot for having me here. It is a pleasure. Good morning, everyone. So as you mentioned, the project is called EBRT 2030, and it's about bus rapid transit. So a bus system which usually runs on segregated lanes with priority at intersection and with an enhanced level of service. The project is called EBRT because it's a double component. So we're talking about electric buses, but also European bus rapid transit. The objective, and the project finances innovations on certain EBRT lines. The aim really at enhancing the level of service or addressing specific issues with the objective to reduce cost, but also reduce also greenhouse gases emission, traffic congestion, and in general favor a model split towards sustainable mobility. It is a very big project, big consortium led by UITP, VEU-based technical coordinator with Professor Omar Eghazi that is here today. The project runs around 3 main lines. So the first one is really to develop technological solutions, both at hardware and software level, to be demonstrated eventually real passenger operation in cities, on EBRT lines. And finally, the last step is really to contribute to a definition of what a European BRT that is electric and that is innovative should look like in the pathways toward 2030. We started in 2023, January of 2 years ago. And where are we now? We are in month 25, 26 actually. So the first year was really dedicated to the conceptual work, so definition of requirements, KPIs, and then the partner started with the development of the innovation, technological innovations, that eventually needs to be implemented in the different use cases. We have 6 use cases in Europe and 1 outside Europe, that is Bogotá, Colombia. In Europe we have Athens, Eindhoven, Amsterdam, Prague, and Rimini. The project also has 2 main lines. So we have electric buses, but also in-motion charging trolley buses. And we have an international component that I will tell you a bit more later on, that really try to exploit what we are doing in Bogotá. The first year, as I mentioned, was mainly related to the conceptual work. This is one of the main outcomes of the project. We drew a report which really described the state of the art of BRT systems around the world, and draws a definition of what a BRT system is for this project, for these characteristics, and we develop also some scorecards to kind of capture the level of the different ambition that we can have on different elements of BRT lines. The report is public, so I would invite you to go on the website in case you're interested. And now we are moving towards the implementation of the technological innovations that you can see in these slides. So as I mentioned, these technological innovations, as BRT is a system and we are introducing an electric component, move along 3 main pillars, so at the level of the vehicle, so the buses itself, the charging infrastructure, and the connectivity and IoT systems. They aim at addressing specific issues or to improve the level of service on certain conditions and reducing cost at the same time. To give you a bit of an indication, for example, here you can see you have hybrid charging system with stationary battery buffer that will be implemented in the Netherlands, because in the Netherlands historically they're very developed in terms of electrification, but I have a very big problem of net congestions. But I will dig a bit into later on. We have also technological, what we call tech to op, technological to operation. So basically a technological solution that will be demonstrated in a static environment, so not with passenger on board the buses. And to give you a bit of an example here, I put 3 of the solutions. So one is like intelligent driver support and safety systems. The second one is advanced energy and thermal management. And the third one is in-motion charging, hybrid in-motion charging systems. So concretely, where we're going to implement this. So Barcelona is one of the use case. Issue to be tackled there is bus disruption and bus bouncing with irregular time headways of the route that we're going to demonstrate here is the H12, one of the premium routes route in Barcelona. So the idea is to implement simulation models to anticipate traffic scenarios and have some workflow that can react to the disruption in order to adjust the headway of the bus. So this could be implemented with, for example, the reduction of the speed, but also like a traffic priority at intersection that could be activated through a connection to the control center. Another example of, and this is probably one of the most advanced demonstration of the project, is what we are doing in Prague. So thanks to the project and to other sources of funding, basically we upgraded a bus line that was connecting the city of Prague to the airport. A very busy line because it was carrying almost 20,000 people per day, plus of course the luggages of the passengers. Now the line is full electric with a double articulated trolley buses that are charging in motion charging for more than half of the line itself. So obviously biggest capacity, transition to fully zero emission because they're fully electric, and they're also implementing other innovations such as an energy management system at the depot, and also some controls that we want to do on the buses. So this is already on. It was inaugurated in March, and we're very proud to, with this project, to be contributed to this. We talked about digital twin all the time until now, so we also developed a simulation platform that actually was done by the VOB team with Professor Omar Ghazi here. So the simulation platform, it is quite interesting because it can simulate different parameters of a bus route where you want to implement an EBRT with different scenarios and adaptability to different characteristics of the city where you want to use the platform. It will be used in Athens, but also we're doing some feasibility studies on the international level and for cities that would like to implement BBRT systems, and this platform for them would be extremely of use. As I mentioned, we have international activities. We just published a call for follower and twinning cities. The call is on until the end of this month. The idea is to have 5 follower twinning cities to follow the project, to eventually implement the innovations that we are developing, or to provide the opportunity to use the platform to simulate the electrification of their EBRT line. We also have a user group, a group of operators and authorities that follow the project because they're interested in learning the outcomes of it. And we also have, we will also perform some small demonstrations. We will publish another call in the next months to replicate some pilots in South America and East Africa. What are the outcomes that we're trying to achieve? So of course is the validation of the technological solutions that we are implementing at the moment. Impact assessment, of course, for a concept of EBRT that is citywide, but also on urban and peri-urban line. Feasibility studies, I mentioned this already, and the conceptual work is one of the main objectives. So the idea is to really have a final report that can guide operators with supporting tools to eventually implement a EBRT system in their cities according to different characteristics. But also we would like to include in this report a chapter on policy solutions. And in general, we seek to have an improving understanding of what an EBRT is and what role can play in sustainable public transport in our cities. Expected impacts is, of course, increased ridership and operational performances. This is key for a bus system. Reduction in emission, traffic, and increased shift towards sustainable mobility. We have ambitious targets, some shift in some corridors, 10–15%, and eventually a reduction of CO2 emissions. Finally, we talk a lot about costs. And the objective also of this project is to demonstrate technological solutions that are valuable, but that can also be implemented in a way that can foster cost reduction of around 10% for the cost of kilometers and passenger, and also the TCO of the operations. Energy savings is also another expected impacts of the project, because here we are talking about electric buses, so we know how much, in order to upscale the electrification of the lines, energy is a key component. And for this reason, the technological innovations are obviously integrating smart charging system and interesting aspects and approaches to electrification. We have one of the key innovation is also trying to improve the in-motion charging of the trolley buses, but for the electric buses, we have peak shaving solutions and digital twins that can really help to forecast some models that eventually can guide operators to the right choices. Finally, it's very important to conclude this conversation is that with the international aspect and cluster of demonstration that we are trying to do is to also try to have a feedback from other countries that have already implemented BRTs, because as you might be aware, the concept of BRT does not come from Europe. In Europe, is applied in different levels, in different scales. So it also is important to foster a dialogue with international partners. The project is also foster European project connections, because it is built on the legacy of another project that was called Assure, that was focusing on standardization. And it also has a lot of connection with Solution Plus, and is another project that finished last year that was trying to foster innovative solution in the Global South. And we are obviously connecting in terms of KPIs with the project Les Mesuriers. So I think that's it on my side. In case you're interested, just like visit the website and you keep following the project in the next years to come.
Okay, thank you. Excellent presentations, very clear. Everybody was on time. Only 2 yellow cards. Otherwise, just absolutely perfect. I would like to, well, I'll do a short summary. First of all, we see 3 projects that have answered the same call, but with vastly different but complementary approaches. So we have to see the fleet approach from ZEFES, for example, eMpower, goes more into a deep dive into the components itself, and Escalate goes more of a tool approach. And then the EBRT, I was very happy to see that we're making progress there. Very nice results. Most of all, I would like to commend ZEFES for pointing out some of the elephants in the room, to really saying, here are the problems, because that's why we're here. If we only show everybody the perfect results, everything that works, we're never going to get anywhere. But if we're using these projects to uncover the stumbling blocks, the challenges, this is what helps to push into the future. And I know there's a DSO back there. I know Elish is here. So let's get the people informed. Let's get them in the room. Let's get some interaction. I don't want to just have, say, a frontal question and answer. I would really like to get some dialogue going here, try to provoke some people here to make some statements. And I know, Patrick, I can see you back there. Maybe you want to make a statement about EBRT. We've been discussing this for about 10 years, so that this is the opportunity. So I have a whole list of questions, and I'm hoping that I won't have to get to my list of questions by motivating all of you to ask really good questions. This is the opportunity, and it's going to be taped, so we can look at it later as well. So I'd like to open the floor to questions. The first one of many. Oops.
Okay, thank you for all the presentations. I'm from Scania in Sweden. I had a question to Professor Hartavi from your project there. We're using machine learning to make the estimations of range and expectations, perhaps also range. What challenges have you encountered in those developments?
Somehow it's okay. Thank you very much. To be honest, the first challenge which we come across is the lack of data, as I said earlier on, right? Because when you are developing the, AI-based techniques, the importance of data is pretty obvious. So this is one of the main challenges. But of course, we come up with some synthetic data generations and etc. As today it's very well known, right? So this is the main issue which we have. So, and also sometimes the lack of the data because of the non-existence of these kind of trucks, right? But also sometimes if we are developing something for the component base, then this is due to the confidentiality of the data. So always the issue which we come across is this one. But also there's a hidden challenge, which I also mentioned, and I try to make it clear in terms of the, you know, the energy consumption of these data, right? Where this data will run is the third one. So we try to consider all of these elements when we are designing. So we have certain specific KPIs to be able to evaluate them and then see how much really energy we consume during these calculations, and if we should run these on the vehicle itself, or should we run this on the cloud, right? So these are the all challenges which we come across. If we can solve this, I think the solutions will be the optimum ones for the developed technology. So these are the three main challenges, I should say. You're welcome.
So, more questions. We have one back here.
Good morning, Friedel from the MAN Truck and Bus. A question to Mr. Gennaro from Empower. What was the reason that you chose for your demonstrators full chassis trucks and not the semi-trailers? Because for long haul, it's the most common part of truck.
Does it work? Okay, yes, it does. The question is why we don't go for an SMI. And this was one of the requirements of the call, as simple as it is. So the call was the topic was asking for trucks of 40 tons, and was giving us the ability to choose to pick one of the vector homologation category. So for the project, we picked up the Vector 9. Both trucks belong to Vector 9. So and we can fit the target of the payload. So of course, what you said about the implementation of SMI is logical. It's a clear logical step. Of course, the tractor that we are developing, it's also fit to other type of application with the trailer. So, but as simple as it is.
Sorry. But then I wonder about the setup of the whole projects from the EU side, because we are tackling the problem of getting to the zero emission thing. Mm-hmm. And the OEMs are threatened to develop those tractors because they have the most CO2 emissions. Mm-hmm. And then we are challenging the projects which are looking for solutions for this third or fourth step in this problem.
Mm-hmm.
I don't know. Yes. Now it works. Yep. I agree with your remark. So when we started to design the project, we have looked into where are the biggest gains, if it is about CO2 reduction in long-haul freight transport. So together with the OEMs which are in our project, you have seen it. It's Volvo, Renault, Scania, and Ford Trucks, and we all decided we go into the tractor units, 4x2, 6x2, and yes, we have also one rigid 6x2, a typical Swedish vehicle, because in Sweden you have the typical application of 6x2 rigid with a 12-meter Swedish axle, 2 axles in the front, 2 axles in the rear. So I believe with that move we have taken the right decision that we put the most attention on the tractor unit, because the place is very compact. So we are confronted with the 900 millimeter more length. We need it. And that's also why I've addressed in the takeaways that this 900 millimeter, the 12 ton on the rear axle, if you have a 4x2, these are really the problems we are confronted now with in the several national or member states, I must say, along our corridor. So I support your remark, and I feel that we have taken the right decision here.
But also it's complementary with the other project because every project has its own approach. I think this is really nice, rich discussion because we cover also the needs of the end user. That is the most important. And also considering the cost and so on, that is really reflecting what we are aiming to. Thank you.
Maybe if I can make a small comment on this, in Escalate we also take into consideration of the vector 12 for the Finnish one because the regulatory requirements are different. You can even go up to 67 ton, right? You can go well above the 44 ton trucks. So there are actually different reasons behind this, apart from these emissions and of course the end users requirements, but there is also, packaging issues and etc. when you are going to develop these technologies. So in Escalate, we consider different vector classes starting from 9. Just a small note.
More question, Guido.
Maybe to get some additional question as well. And thanks again, Guido Sacchetto, DG Research Innovation, European Commission. Just a generic question to all of you, just to understand how you're approaching the digital twin, because all the projects are doing and work on digital twin. So how do you plan? Where are you at the moment? We heard something quite detailed on ZEFES, maybe less from the others. And how are you planning to use it? How open is it going to be? And how useful for the users? Thank you.
Yes. Yes, I think we had also presented a very nice tool, decision tools and also selling tool that we are. And from Avito cluster, this is the also added value for Avito cluster that we also will launch also working group to make a synergy between the tools. Because if you develop a tool X and Y and Z and there is no synergy and there is no key definition, that will be a bit of a challenge for also the end user. So the idea there to launch also working group that also I appreciate also Simon here also that will be leading this one later from Ricardo side with our colleagues also on other projects. The idea is to really make a common definition of the digital twin. Because also yesterday I heard a lot of discussion also about logistic tools, models, and digital twin as well. We need to see how we can make a very nice synergy. The common definition is really nice to be used and also standardization that it is required for this. I come back again to the data, digital tools, digital twin needs also data. Of course, data that we need to really look at the future with launching maybe data center Europe, different area, different region. I don't know how will be tackled later. Also that will ensure also the availability of the data, regardless also the confidentiality and so on. That would be nice to also be in line with AI, machine learning in the future. Thank you.
From the Empower side, of course, we are developing simulation models for all the components that we are implementing on the 2 demonstrator. So we have a simulation model for the energy storage, energy conversion, traction, and these digital twin models are embedded into a master framework that can be used from the vehicle side to understand how to best operate the vehicle and how to go towards eco-routing. One of the parts that I did not present among the results was a system of eco-routing. Also how to manage all the auxiliary system on the vehicle. And then the same models can be used from the operator side for best optimize the logistic. So another element that I did not present for a matter of time in my presentation was the presence of Gruber Logistic as one of the operator of this vehicle. Of course, as these vehicles are deployed on the roads, one can start to harvest data, and one can imagine, let's say, more exotic, more complex. We have seen machine learning, AI, although I still believe that the real utility of such models needs to be proved. So at the moment, what we have in terms of deterministic model is quite good, and we can already do a lot with that. Of course, the more data, the different models you can train on, for which end use case and which utility we will see.
Maybe I can also explain a little bit the Escalate approach, how we use this digital twin models. First of all, I think we need to clarify one thing. When we are talking about the digital twins, we are not talking about unidirectional communication. We talk about the bidirectional communication, which I believe fulfill exact definition of the digital twins. So we have, I can say that we have multiple users for our digital twins. One of them is the original equipment manufacturers, which they can use this to optimize their designs, right? So this is one of the functionality which we are targeting. And the other one is the, fleet operators, of course. So they can use some of the softwares as a services through these digital twins, like the remaining useful lifetime, reduced downtime of these trucks, right, which is quite important from the end user perspective, and also the, range estimations, again, to be able to, select their routes. And apart from that, of course, we also use the digital twin to do the optimum, to select the optimum routes for the fleets, especially when you consider the different type of solutions, right? I think one of the uniquenesses, again, within the Escalate is we develop modular digital twin solutions, which also enable you to come up with using these, models, let's say the digital models, to be able to build up different type of, vehicles and classes, right? So that it will enable you to, implement and then to make use of this. So these are the multiple functionalities which we are making use of through the digital twins.
Yeah, I mean, just to complement the same thing for EBRT, I mean, on the one hand, we would like, for example, in Athens, they have these very small pilots where they're running just like a few buses. And of course, a digital twin, it's very important for them to collect data in terms of like passengers, load, but like characteristics, usage of the components to eventually upscale this pilot with more buses and understand where to go in terms of like requirements, characteristic of the route, charging systems, and so on and so forth. And then we're going to use this simulation platform because it can really simulate environmental conditions as well for operators that are interested in doing feasibility studies to eventually insert a BRT, select which corridor is actually more appropriate for the demanding requirements that they have. So, but of course, exchange of data and continuous harvesting of data is key in this respect.
Comment yet to complete what my colleague was saying on Escalate. I think we have to take into account now when you're talking about digital twin on our case, we are talking about the truck, the environment. That means all the simulation of where we are running, where the trucks are running also, and taking into account all the ambient condition. And therefore, when you are running, it's two pilots that are running, one physical and one virtual. That there's really two things are running in this real-time base, yeah? And therefore, we buy the direction and information from one to other, and therefore we have to adjust and use, the information you can get from one to optimize the other one, yeah? That means we need a lot of security information to be taken into account before changing parameters of the truck, for example, yeah? That we have to manage a lot of things concerning cybersecurity and safety also, yeah, on that.
Okay, thank you. More questions? Okay. Elish, question back here? And from Simon, you have a question? Okay, good.
Thank you very much, all presenters, for this very nice presentation. Similar as Ian said, also I have a lot of questions, but I will only focus to only one. That considering our business, I'm Janes Humaran, coming from the LS, Transmission Distribution System Operator. Now, all the presenters somehow emphasize the challenge of the DSOs, of the connections, of course. And with respect to this, I have a question with respect to the MCS system. We all know that MCS system is critical if we would like to recharge the trucks in these 45-minute stops. And as the name MCS suggests, this is a mega charging systems, which implies that the charging should be at least 1 megawatt per each truck. Now we have a challenge here, because all the charging stations are actually, at the time, as far as I know, connected to the low voltage. Is this correct? To 0.4 kilowatt. And well, from the grid restrictions, we know that low voltage should only go connectivity up to 300 kilovolts. We have here 1,000 kilovolts. So this is perhaps one issue. And now the question, have you considered perhaps with your partners on the project like Empower and similar, would there be a possibility to connect these MCS chargers directly to the middle voltage, to 20 kilovolt, and to avoid the transformers? Because as far as we see, that means 1 megawatt means 1 transformer for each truck. This is a lot of space, a lot of copper, a lot of iron. On the other hand, and we don't have abundance of these materials, but on the other hand, the power electronics, in Europe we are very strong on power electronics, so why not connect power electronics directly to the 20 kV? I know that such systems, such designs already exist, and we avoid a lot of problems, plus that there would be additional, I don't know, competitive edge of the European industry if we design something like this. Thank you very much.
Thank you for the question. I think the challenge is somewhat more complex. The reason we want to introduce these MCS chargers is to combine in a way drive and rest times in combination with charging. So if you want to use your 45 minutes, you need 1 megawatt. Now take a motorway of about 250 kilometers length, and each 60 kilometers, the guideline is we should have charging points. During the day, it can happen that at each parking place where trucks arrive to make their pause and they want to make use of charging in the future, it can be 10 vehicles, it can be 20 vehicles, and you have to program, you have to set up a sequence. How can I then charge these trucks? So today you are talking about only 1 mega charger as we are now in the startup phase, as we are in pilot phase. But if we now are 5 years ahead or 10 years ahead, then we have a lot more electric trucks crossing these motorway sections. And then, of course, at each parking area, you need not only 1 MCS charger, you need a number. So, and what we see now through the corridors, along the corridors in Europe, which we are trying to set up the demonstrations, that the DSO market, the grid market, is very segmented. You have many grid providers, and that makes it already difficult to make the first step. How can you find out who are these grid operators? How can I set up a dialogue with them? And how can I set up the discussion? How are we going to develop this now that at each 60 kilometers you have the possibility that you can charge trucks, whether using MCS or using CCS, because you have the combination at the beginning of the night and then during the night of MCS and CCS. So this is a very complex issue, and I'm very happy that you are now here today, because we are really looking for is somehow an overarching organization about DSOs, so that we can start to talk about this strategy. And I like your remark that with the high voltage we can maybe skip a trafo, because we are confronted in ZEFES that we are now buying a trafo, because to make it simple possible. So you can imagine that we are really burning money when there are other solutions possible. But we cannot go for the other solution because, yeah, in the complexity of the discussion. So I really would like to see that somehow we can set up this dialogue with the association of DSOs whenever it exists, and that we find out along the corridors in Europe to whom should we talk and to whom should we involve in this discussion in first phase, because it will take some time before you have really a scaling. So that is my first reaction to your question, and I return it with 1,000 questions. How can we start this? So I'm very happy that you are here. That's for sure. Maybe a good start.
Yeah, but also if you flash back 10 years ago, did we consider mega charger? The answer is no. It's correct. Now we are facing this challenge. Yeah? I would like to recommend you that you follow the new project. It's called FlexMCS. We are considering this study there, and also the sister project. I think that is really good exercise that we add also these projects in the Avito cluster to learn from each other. Thank you. Yeah, I think it's more than 1 megawatt, so it's 4 and 10 even.
Yeah. Okay, so from the Empower perspective, I didn't mention MCS in my presentation, simply because we decided not to have MCS on these two demonstrators. The battery electric is equipped with a super fast charging, so it's 350 kilowatt peak. And the end user requirements, together with the emission profile for the regional battery electric truck, does not require the installation of a megawatt charger capability. Said this, Omar already mentioned FlexMCS, where we are planning to make a modification to our battery electric demonstrator for equipping it with the MCS technology. Not sure that this will be useful. I mean, it's important to master technology, but it's also important to make a right decision about the technology. And depending on the development of battery electric-driven trucks against fuel cell electric-driven trucks, we might need or we might not need the mega charger. I tend to agree, and this is my personal opinion, not the opinion of the consortium, that maybe the megawatt charger is a little bit an overkill for this type of application. We might have plenty of mission profile routes where we simply don't need it. And the detrimental effect that the megawatt charge has on the battery of a vehicle is something that we have to consider in the game. So having a super fast charge of the battery might really kill it. And we know that this is a technology that we're really keen about it because it's the most expensive component of the vehicle. I do see a value in developing a narrative and developing the technology. It might be that we need megawatt charging in other applications, not in road transport, and that's where I see more potential, personally.
Yeah, maybe we mentioned the megawatt charging system in Escalate project, where we also consider the waste heat recovery. To be honest, a simple answer to your question is, from my own perspective, first of all, yes, of course, the power electrons will be more compact, right, more efficient. But on the other hand side, you should consider the reliability aspect, the advanced thermal management system, because you will end up with big power electronic components where you need, advanced thermal management solutions. And of course, considering the fact that the probability of the failures that you come across with the transformers with respect to the power electronic components where there are still, then is, of course, with the transformers, it is less, so which increase the reliability. And at the end of the day, also the cost. So in summary, that is why we go with this direction, even though in the scope of the call, which we go for, is not the main thing, but we know the necessity of the megawatt charging solutions and the high refueling solutions for these zero-emission heavy-duty vehicles, so that we cover this in the scope of the project. So that are the main reasons why we go in this direction rather than the power electronics.
Does it answer the question? I think we're getting there. We're getting there. Simon has a question.
Thank you. Thank you to all the panelists for a great set of presentations in the first place, and also the discussions and people showing Le Mesuré project, which of course I'm appreciative of. Simon Edwards, AirTrack, and Ricardo, by the way. Sorry about that. I have a couple of questions, if I may. understanding question, which I didn't get a chance to ask at the beginning, and then maybe a more general question. Understanding question to EBRT. You mentioned two terms that I didn't understand. Narrow navigation. What's that? In relation to Volvo, I think it was. And secondly, you're changing the commercial speed. What's that? Can you explain how the commercial speed is changing? But then more generally, we're talking about changes in the capacities of the vehicles, in the logistics operations. Target was 90%, for example. Does that mean we need 11% more vehicles on the road? What's the people's thoughts about how the number of vehicles on the roads is going to change to maintain or extend capacity? But let's give EBRT a chance, first of all. Thank you.
Thanks for the question. For narrow navigation, we intend like very semi-automated docking maneuvers at a bus station. So that's like basically yeah, some devices that can help docking, properly aligning the bus at the bus station. This is very useful for EBRTs. Why? Because the bus stations have different characteristics usually when we talk about bus rapid transit, so the higher platform, bigger, usually in the middle of the road. For commercial speed, this is the speed of the bus, in the sense if in a corridor we're talking about 12 kilometers per hour, probably with a BRT, we try to increase it to 15 or something like that. So that's the no worries.
Yes, to come to the second question, or the third question, about the weight of the vehicles. You have to differentiate this question, because it really depends on the logistic mission you are performing. One mission, we have the transfer of parcels between depots. So that's the parcel pipeline, we call it. So that parcels are in swap containers, and they transported from depot to depot. There, the weight will not be a critical issue, because parcel is you are moving air, because everybody buys something which is big like that, and you get a big carton to house, and the rest you throw away, and you have this. So that is not so critical. The corridor for the fresh fruit, this is highly critical, because there we talk really about 20 to 23 ton of cargo, and we know that these trucks will be simply too heavy. So the European directive sees that we can drive at 42 ton. In reality, this vehicle will run 44 ton, 46 ton, and I know all the people say, yeah, Ben, that's too heavy. Yeah, but the consequence is that on this use case, we will see that the consequence will be that Prima Frio in this case will need to do one transport extra per week to compensate the loss of cargo, because when the law says you are at 42 ton instead of 40 ton, then you may not drive as 44 or 47 ton. That's very clear. So it really depends on the missions. As said, fresh fruit, parcels. The other missions we have in our project is general cargo and automotive. With automotive, you have always the challenge that it is the forward trip, because that is the heavy stuff, and the backward trip is emballage, so the rolling containers. So, and there we will see together with the OEMs, because they are going to operate the automotive pipeline chain, how we can cope there with handling the weight of the vehicle. Then we have heavy steel. Yeah, there we really are, this in fact easy, because those vehicles are loaded on a bridge, weight bridge. So, and it's in Sweden, so in Sweden we can run 64 ton. So in Sweden I'm not worried at all. And the general cargo is most of the time within the weight, because in general cargo you also regularly are transporting air and a little bit of cargo. So I say in certain missions, you have to reckon that you will have an increase of 10 to 15% of trucks, especially the pipelines of food. I look at the supermarkets, they are really critical because this is always fresh fruit. One much more important thing, Simon, is because of this weight issue and because of this, how you have to tune your weight to the allowed weight, is also the time slots these people are confronted with. Because each, in the parcel business, you have time slots. You have 50 minutes to enter a depot. And after 50 minutes, you have to get out, whether you have dropped your load, yes or no, because this is a really tacted issue. With the fruit pipeline, I have to catch the boat, because if I don't catch the boat, I lost the load. I have to catch the charging station, because if I miss the charging station, we can in the meantime write a book. What happens when the truck doesn't reach the charging point? And this is a much more critical point than the weight. And what I touched already in my earlier presentation, it's the 900 millimeter length. We all have not talked enough with the rail people. And that's why we have integrated the rail people in our project. We are doing a specific test to put our vehicles on the rail wagons to test whether they fit. Can we charge these vehicles on the rail? Because long freight transport is intermodal. It's the ferry, it's the train, and guess what happens with the ferry? Not each ferry is taking our truck. So in the worst case, we have to divert from Hamburg through Denmark, make a long detour that we enter Sweden instead of taking the ferry. So these are things we have to focus, and the weight I see more as a typical mission area where we can be confronted with weight issues.
Thank you.
You have a question?
Well, nothing really to add from my side. So the answer of Ben, I think it's common to all of us, and it's completely exhaustive. It depends, of course, on the mission profile. So just the quick answer to your question, Simon, is yes. In certain cases, we will need more vehicles, but that's nothing new under the sun. So.
Maybe one point which I would like to highlight is actually statistics says totally the opposite, right? So they said, due to the volumetric, issues, you never really load most of the trucks to its full weight. Right? I think this is the point which we shouldn't underestimate, because then you tune everything according to the 40 or 44 ton, but you most of the time, at least based on our discussions and the statistics, I know that that's not always the case.
So I have a quick question, Ben, and Eric also has a question. The question I have is, what percentage of the transport trucks on the road are fresh food, roughly?
That is really challenging. It reduces definitely.
If you allow, I'm not going to say a percentage, because then maybe I'm lying.
No, roughly.
No. What I know is that the fresh fruit you should take into also the supermarket deliveries. Yeah. Because an ordinary supermarket has 2 times a day a truck which is entering with 15 to 20 ton of fresh food. So, and if you look at that market size, you are really entering in a double-digit market size. So I get this comment often, hey Ben, fresh fruit, is that really important? Well, I think if I go to the supermarket, I want to have fresh fruit or not. I mean, I don't want to have a box where the fruit is dried. Yeah. So, and that is maybe the comment I want to make. In ZEFES, we have really looked at those logistics which we all use every day in our daily business. We buy an internet, so parcel is key. We want to have fresh fruit. We want to have fresh food. So fresh fruit is one of the keys. We want to drive a car, so we need steel. So I can go on. So what we did in the ZEFES project is, how do you have to look at the freight transport in Europe? What are the streams of cargo and freight? And that we have really chosen very carefully with the logistic service providers, the shippers in our project, because they have to solve the topic of, can I buy an electric truck? Not we in this room. If they cannot solve, this is the way I can run these trucks, why should they buy these trucks? So we have to turn around the question and stop talking about, oh, is that important? No, we have to convince him he should buy these trucks. And it's not buying, it is leasing the trucks. I look at Mats. Go to the business people of a truck manufacturer. These are lease contracts, so you have a buyback. Yeah. So after 2-3 years, you get these trucks back. You have to resell them again. Yes. So these are the discussions we are talking about. And if we don't get that right, why should I buy this truck? And that's why we have chosen these logistic missions, not because of the fun.
And that's why we basically have 3 big challenges here.
By the way, Simon, bananas are the leading fruit types according to the statistics when I checked, okay, in terms of delivery of the fresh fruits.
we have 3 challenges. We have deployment.
65%.
That's exactly deployment. Yeah, we have to get this on the road. We have to get the logistics companies using these trucks. Eric, you had a question?
Does it? No, yeah. Okay. I have a light question after this discussion, and then maybe we give the floor to Guido. Is actually, you mentioned several times the cluster. So I would like you very quickly to develop about this cluster that you have set up. Of course, this is something that from European Commission side we push very much. We see an advantage of having the cluster in place. You can exploit synergies coming from the cluster. You can set up workshops, work together. So considering that you've mentioned several times, can you please develop a little bit on this? I think this is a transversal topic of interest for everybody. So if you can talk about your experience with the cluster, your experience about setting up the cluster and how it works, and how you leverage on the power that this tool, which is the cluster, can have.
Yeah. It's working. Okay. Thank you, Eric, for a very nice question. I think it's not light, but okay. Indeed, the cluster was a very nice, fantastic idea, because at the project phase, we know that there is another project will be granted. And the idea is to have common understanding of the needs of the end user, because we are going to sell the car or the truck to the end user that they are interested in. So our goal and our vision there to have really what you call creating a strong impact from heavy duty. We are heavy duty projects, and I think this is the right message that we need to align together to have really common understanding for common topics like TCO, LSA. I'm happy that today that we have launched a very second, I think this is the second workshop, to really create a position paper on that. We need to get a win-win situation. We transfer what we have inside, what are the challenges, and we let the Commission to know also all the concerned people that are working in this heavy-duty domain. This is the right message. Second one is the digital twin. I heard also digital twin activities, different angles. I think we need to create a baseline, what I call baseline definition for the digital twin. Again, a crucial thing is the data. So how we handle this data? Of course, there is confidentiality, but we need to have really to account on really a collaborative way, of course, with partners and also end user, shippers, also logistic companies share more data as they can. Because, okay, we come back. We didn't hear about digital twin before. Engine-based diesel trucks, It's very, I'm not mention simple, it's really standard. There is no huge data there. The engine is working. You have the refuel station after 6 kilometers. There is no worry. It's correct? That is the point. But nowadays, electric cars, battery, huge challenge. Everything has aging, degradation, failure. How we are going to handle this one and advance it? We need to align also predictive maintenance. How we are going to do that? We need to help the logistic company. We need to help them to take the right decision. Okay, how far to do the electrification in your fleet? We have doubt because the cost. The cost of the car is 3 times, maybe compared to the diesel. Maybe it will come down. The charging, how we can do that? Also road construction, regulations is nightmare. I think that is really the important thing that we are going to tackle in our cluster. So second one is that milestone and work, what we call white paper with position paper for us from a V2 cluster on baseline digital twin. The second one, again, I highlight also the infrastructure, energy, the integration with the grid and so on, refuel station. Hydrogen is green or non-green. Is also a lot of discussion there, 300 bar or 700 bar. Okay, we need to figure a solution. And of course, it's not coming also from innovation projects. Yeah. Of course, we need to have private investor. Companies should lead the decision. State should be invest. As been also highlighted that we need to have a fast charger, CCS at least, every 60 kilometers. Like the diesel now, diesel station. We need to tackle this. Are we hoping to do that? Yes, we need to have really launch a very nice massive deployment of this battery electric vehicle. I heard also some news about that. I hope that will be fast. Very nice to highlight also, don't to be late to regret. So we need to lead in this. This is a chance that we lead in a heavy duty electrification. And I think this is the opportunity. Thank you.
May I also make a comment on this? Actually, we can't, I think, underestimate the value of coming, I think more than 60 partners are coming together in this cluster, right? So as you can see, to Escalate with 37 partners, ZEFES and Power, and also there are others which are also joining. So the knowledge exchange is amazing, I should say. But also we have different working groups, right? So one of the working group is led by Escalate project in the Aveto cluster. Thanks to ZEFES, he is leading the LCA and the TCO side, which is quite important one. And as Omar said, there are other 2, but there's also another one which we can't, again, ignore the importance of it, again, which will be led by Escalate related to the AI working group. So we have different working groups under this cluster. So I think even though, of course, not all the 60 or 70 partners are coming together, at least we have some kind of a knowledge exchange at a high level, and we can also try to come up with some recommendations all together, considering all different perspectives of these clusters, because each consortium come up with their own techniques to solve the challenge that the zero-emission heavy-duty vehicles come across. Some of them, as we see from the hardware side, some of them are more dominated with the software side of solutions. So I don't think that we can ignore. And of course, it's not just unique to heavy-duty vehicles. All the projects until so far which I joined in the EU projects, we always value the importance of the clusters, and then we build clusters.
I think it's quite clear when we've come to 11:01 and Ben is threatening to leave. And every time I listen to Ben, I make a whole sheet of notes. So you know that's quite interesting. I think everybody's really profiting from this discussion. Maybe some final statements. Guido, do you want to say, do you have a question?
Yeah.
if everybody agrees, if everybody raises their hand and say, yeah, we want to stay for a few more minutes.
Again, one more question. Yes,
We'll have,
pleasure.
one question, one answer, okay?
Well,
and the other one gets the geld.
But really short one. No, I mean,
okay,
really short question for you. Well, first to recall that, of course, we do this kind of projects also to gather some political feedback, and this is why we don't need to focus on the niche market. Even if really relevant for the consumer, I know it, but we need to understand the whole chain so to gather the main points, and this is why we're doing this. So I understand the importance and relevance for the consumer to have the fresh fruit, but maybe from a logistic point of view, that's not the base case ever we need to investigate, even if it has to be included as well. Not the main one, just that. And also, the main point of all this is e-mobility. It's not the vehicle, but it's the system. So my question would be, how are you linking your activities with all the development and deployment of the charging infrastructure under the ZEFES, the AFIF directive, but the member state with the recovery program that they're deploying a wide range? Are you following that in the activities that you're doing? Thank you.
We have one answer, and I'll give it to Omar.
Yeah, okay, thank you.
As sort of the veto
I think the answer is very simple. We consider a system of system. So we come from the needs of the logistic companies. I know there is also some use cases that already covering niche market, that is true, but also we never ignore it. So we need to consider also requirement there, the specific that need for efficient logistic system. The idea is to accelerate the electrification in this domain. And if we didn't do that from different angle, of course, again, we'll be late. And I don't like to be late again, so please, we need to keep the word of regretting again. I think that is the best way to do, to work together, and that's the idea of cluster, a video cluster, to see also the needs from another stakeholder, from other projects. Did we consider it, yes or no? Can we consider also the DCOs? Yes, for sure, the need there, because we are going to deploy massive mega charger, fast charger on the road. That would be nice. Do we need to change also 10T corridor? Yes or no? Do you need to upgrade to consider also another road? Yes or no? This is the most important system of system. Yeah. Thank you.
Maybe I can add one thing on what Guido said. No. I mean, the power system is always underrated. You are completely right. Electrification is a systemic problem, and in order to tackle it, you have to look at the system overall. I have the luck of leading a group that has many projects across very diversified range of technologies and application. And one example that sometimes I bring of how we can do a system is, for instance, the link that we can create with projects like Empower, ZEFES, Escalate, and other projects which are running under the Horizon program, for instance, under the Green Airport Call. I mean, under the Green Airport Call, we are partnering with the Airport of Malpensa, which is building a large-scale electrolyzer at the cargo bay area of the airport. And this electrolyzer is designed to basically refuel the fleet of 40 tons truck, which come and go every day from the cargo area to download and upload the incoming aircraft. And at the same time, we are studying into another project, which is funded under the Clean Hydrogen Partnership. It's called Ticino. It's in the Green Valley, where this electrolyzer is also used together with a liquefaction station to prepare to what will be the future of liquid hydrogen powered aircraft. So it's really a systemic approach. And when you look at the full system, you can see synergies across technologies. So it's really important to have this bird eye view on the overall system and overall electrification.
So we need to thank you. We need to close now.
Sorry, can I just make one comment? Ian? You promised me 8 minutes, right? I just remind you. So anyhow, yes, it is, but I think also we need to consider not just 10T and 10E. If we are really considering a holistic approach, I think we should consider both of them and then what we are trying to do in Escalate. Okay?
Okay, thank you, thank you. So thank you. A round of applause. And one final statement from my side. You can all see electrifying heavy duty is the Iron Man.
Yes.
This is the Iron Man, and it's not done with one project, it's not done with two projects, it's done with a cluster of projects. It's done by the partnership, and the partnership is the only way to do this. This is the most important reason we have a partnership like this. So I'd like to thank the speakers, I'd like to thank the audience for the very good discussion, I'd like to thank everybody. Coffee break, we've taken away some coffee break, but I think it was okay. Starts at 11:30 is the next presentation, and looking forward to seeing you all at lunch, at the latest. Bye-bye.